Hello everyone. In this video, I'm going to provide you an example question. I'm going to complete one question, which is question one. I want to use that as a reference to complete the rest of the questions. So let me start modeling question one. Here is a graph. We have time and velocity. Calculate the rate of acceleration from 0 to 10 seconds. Acceleration is change in velocity over time. So whenever you have the question on acceleration or deceleration, you need to find out the gradient or the steepness. You need to find out the gradient of the line that would help you. So I'm going to use a simple concept of change in x over, change in y over change in x. Or you would have known as rise over run. So from one point to, I'm going to rise until 8 because it's from 0 until the 10 seconds. Rise until 8, and then I'm gonna run from 0 on the x-axis all the way until 10 on the x-axis, which is the time. So the acceleration is the gradient, which is m equal to the rise is from 2 until 8, which gives me 6 meters per second divided by the run, which is from 0 all the way until 10, which will be 10. So 6 divided by 10, you could leave it as a fraction or convert to a decimal number, which is 0.6. I repeat, the acceleration or deceleration is calculated by you finding out the gradient. The gradient formula would be rise over run. That's rise over run, and that helps you to complete. In the next question, we're trying to find the rate of deceleration from 0 to 10. You are going down, so it would be a negative value, and hence it's called deceleration. Notice I've just gone until 5 on the x-axis, and then I'm running across because it reaches the end of the square rather than in between, because it's harder for me to calculate the value of y. So here in this case, it would be from 8, it's gone down to 5, so it's negative 3 divided by the time is 0 all the way until 9. That will provide you the rate of deceleration. And finally, let's calculate the distance traveled. As mentioned in the video earlier, the distance traveled is the area under the graph. So the calculate total distance traveled is from 0 until 40. So that's the area underneath. Either we can see this as area of trapezium and we can calculate it, or break them down into basic shapes. So I have broken it down. So the area of this rectangle would be 2 times 10 because the height of the rectangle is 2 and the width of the rectangle, of the length of the rectangle is 10, which would be equal to 20. Now the unit used for the distance is meters, because If you look at velocity, it says meter per second. Then we calculate the area of the triangle. The area of the triangle would be half times base times height. We know the base is 10 times the height is, it's not 8, it's from 2 until 8, which is 6. So it's 6 times 10 is your base divided by 2. So 60 divided by 2, which is equal to 30 meters. Once we calculate the distance traveled in segments, we need to find the total distance traveled, which will be 30 plus 20, which is 50 meters. I have done example question 1, as many students have requested that they're finding it difficult to use this video and the example as a model and complete the rest of the question. As usual, if you have any questions, please enter on the private comments in the Google Classroom. Good luck.